Hello and welcome back to the Master Civil Engineering, and in this video we will learn that how to find the pile group capacity in sands. In the earlier video I have shown you how to find the pile group capacity in clay. You can watch this video if you want to learn that. And in this video we will learn that how to find the ultimate load capacity of the pile group in the sand. I have been given a question which states that a 9 pile group arranged in a square pattern is used as a foundation for column in sands with angle of internal friction equal to 32 degrees. These piles are 300 mm in diameter and 10 meter in length and are placed at a spacing of 900 mm in each direction. We have to calculate the ultimate load capacity of the pile group, assuming that the unit weight of the soil is 18 kilonewton per meter cube, and we have to use this Berezantsev's recommendation for bearing capacity factor, which is NQ. First, we will see what we have been given in the question. So since these are concrete piles, angle of friction between the pile and the soil, this is given as 3/4 of the internal angle of internal friction. So it will be 3/4 of 32 degree, which is 24 degrees. Since this is a loose sand, so lateral earth pressure coefficient, this will be equal to 1. Diameter of pile is 300 mm, or you can say 0.3 meter. Critical length of pile. So in sands, we have a concept of critical length of pile, which is the length of the pile up to which the unit point resistance increases in direct relation to the depth. After this depth, the unit point resistance remains constant. So for sands, this critical length, this is usually between 15D to 20D. 15D is for the loose to medium sands, and 20D is for the dense sand. So we have this medium sand because the angle of internal friction is 32 degrees. So we will assume that critical length of the pile is 15D. So it is 15 into 0.3, which is 4.5 meter. It means the effective stress, this will increase in direct relation to the depth up to 4.5 meter depth. So limiting effective stress at 4.5 meter depth, this will be 18 into 4.5, which is 81 kilopascal. After this depth, the effective stress will remain constant. So from 4.5 meter to 10 meter depth, unit point bearing resistance and unit skin friction resistance, this will remain constant at the value of 81 kilopascal. Since we have to use the Berezantsev's that is chart for finding the bearing capacity factor, so this is the Berezantsev bearing capacity factor chart, in which we have the on the horizontal axis angle of internal friction, and on the vertical axis we have bearing capacity factor, and we have these curves, which is the ratio of the length to the diameter of the pile. So for phi is equal to 32 degree and L by D is equal to 33.3, you will interpolate from this chart and you will get the value of bearing capacity factor as 27. After finding the bearing capacity factor, next is unit point bearing resistance. This is simply the effective stress multiplied by the bearing capacity factor. So it will be 81 kilopascal, which is the limiting effective stress, multiplied by the bearing capacity factor, which is 27. So it will be 2187 kilopascal. Unit skin friction resistance, this is given as average effective stress multiplied by lateral earth pressure coefficient into tan delta. So you can see the this is the effective stress diagram for this pile. So up to the length of 4.5 meter, the effective stress will increase, that is it will achieve the limiting value, which is 81 kilopascal, and from this depth, that is from 4.5 meter to 10 meter depth, it will remain constant. So sigma average for over the length of 4.5 meter, this will be 0 plus 81. Simply you have to find the area of this diagram. Okay, so it will be 0 plus 81 divided by 2, which is 40.5 kilopascal. This will be the average value of effective stress over the length of 4.5 meter. Unit skin friction resistance will be 40.5 into 1 into tan of 24, which is 18 kilopascal will be the unit skin friction resistance for the length of 4.5 meter. skin friction resistance. This is unit skin friction resistance multiplied by the surface area of the pile. So it will be 18 into pi into 0.3 into 4.5. So it will be 76 kilonewton will be the skin friction resistance for the length of 4.5 meter. Next, we have to find the skin friction resistance for from 4.5 meter to 10 meter depth. So over the length of 5.5 meter, the value of effective stress remains constant at 81 kilopascal. So average stress, this will be 81 plus 81 divided by 2, which is 81 kilopascal, okay, or the area of this rectangle, which is 81 kilopascal. So the average, the unit skin friction resistance, this will be 81 into 1 into 10 of 24, which is 36 kilopascal. Skin friction resistance, this will be unit skin friction resistance multiplied by the surface area of the pile. So it will be 36 into pi into 0.3 into 5.5, which is 187 kilonewton. Total skin friction resistance, this will be skin friction resistance for a length of 4.5 meter plus skin friction resistance for the length of 5.5 meter. So it will be 76 plus 187, which is 263 kilonewton. Next, point bearing resistance, it will be unit point bearing resistance multiplied by the cross sectional area of the pile. So it will be 2187 into pi into 0.3 squared divided by 4, which is 154 kilonewton. This will be the value of point bearing resistance. So ultimate load capacity of the single pile, this will be point bearing resistance plus skin friction resistance. So it will be 154 plus 263, which is 417 kilonewton. This will be the ultimate load capacity of the single pile. Since we have to calculate the ultimate load capacity of the pile group, so in sands, if the spacing between the piles is less, then the efficiency of the pile group will be less than 1, okay. But in our case, we have been given the spacing of 900 mm. So when the spacing between the piles is large, then the efficiency of the pile group, this can be 1 or even more than 1, okay. Because in this case, the pile group tends to behave like a block, or you can say a equivalent single pile circumscribing all the piles in the group. So we will assume that the efficiency of this pile group is 1. So ultimate load capacity of this 9 pile group, this will be 1 into 9 into 417, which is 3753 kilonewton will be the ultimate load capacity of this pile group in sand. So this is how you can find the ultimate load capacity of the pile group in sand. I hope you guys learned something new from this video and enjoyed this video. If you find this video helpful, please subscribe to my channel and share this video. Thanks for watching and stay tuned.